Let's analyze and solve contains duplicate coding problem. We are given a zero-base array of integers called nums. The array is unsorted, and we have to return true if that array contains a duplicate. Otherwise, we have to return false. And from the coding point of view, we have to write a function. The function name could be contains duplicate. And the function will receive one argument, our nums array or nums vector, and it's gonna return a Boolean value, true or false, depending whether there is a duplicate in the array. We are also given a set of constraints. The most important of those constraints is that array is never empty. So the key points are that the input array is never empty. It's an array of integers. The order of element doesn't matter, so it's not sorted. And we only care about whether the duplicates exist, not which numbers repeat. And that's the entire problem. To solve that problem, we can start from a brute force solution. And the brute force solution is very simple. We will scan through the entire array, starting from the beginning and moving towards the end of the array. And for each element, in this case, we are starting from index 0 and the value is 4. For each of those positions, we will scan the rest of the array, starting from the element following the current element. So we would start from the index 1. And we will be comparing whether the values, in this case 2, is equal 4. It's not equal, so we will move to the right, we will compare 7 and 4, they are different, and so on. So basically, we are searching through the rest of the array and looking for the current element. And since 4 does not exist in our array, this scan would end, and there would be no duplicate found for 4. So we would move in our main scan to the next element, to 2, and we would repeat the process. So in our inner scan, we would start from the element with index 2, and we would go through the rest of the array and search for the value 2. The value doesn't exist, so we will not be able to find a duplicate, and we will move to the next element, which is element with the index 2 and value 7. And in our inner scan, we would start from the next element, which has index 3, and we will be searching for 7, and we will find 7 here in the last position, and we will return true because we found the duplicate. So this is a brute force algorithm which basically searches starting from the beginning, gets the value, tries to find that value in the rest of the array. If it doesn't exist, then moves to the next element, does the same until we reach the end of the array, which indicates we didn't find any duplicates, or we can exit earlier if we find a duplicate. This translates to writing two nested for loops, and as we know, the time complexity for this type of algorithm is O of n squared, where n is the size of the array. But the space complexity is good, it's just O of 1. We are not using any additional memory, and that's the idea for the brute force algorithm. A different way to solve that problem would be to first sort the array, assuming that the problem allows us to change the data. And I already wrote the same array as we used before, but in the sorted order. And once we sort the array, what we can notice that if there are two or more numbers with the same value, after sorting, they will be next to each other in the array. And we can take advantage of this property in the following way. We can start from index 1, so we start from the second element in the array, and we will compare it with the previous one, which is the index 0. And 2 is different than 1, so this is not a duplicate. So we are going to move to the next element, and again we are going to compare it with the previous one. And these are different, so we move to the next element, which is 7, and we compare it with 4, which is the previous element. They are again different, so it's not duplicate. and we move to the index 4, where we again have 7, and we compare it with the previous one, which has index 3, and these are the same. So in this case, we could immediately return true because we found a duplicate. If the array has no duplicates, we will never find the same number twice in that array. So we will reach the end of the array, and in this case, we are going to return false. The time complexity of this solution is O of n log n because of the sorting, and the space complexity is O of 1. We do not use any additional memory. So comparing to brute force solution, our time complexity is better. And that's the idea behind utilizing sort to solve that problem. There is a linear time complexity solution for this problem, and it uses set. So let me explain how that works. We will introduce a set data structure to our solution, and the set has two important properties from the point of view of this solution. First one is that we are able to quickly check if an element already exists in the set. And the other one, which we will be using, is that we are able to add elements to the set. So we initially start from an empty set, and we are going to scan through the entire array starting from the beginning. And for each position in the array, we will be doing the following. First, we will check if the current element, which is initially 4, exists in the set. It does not, so we are just going to add this one to the set. And we will move to the next element. 2 is not in the set. We are going to add 2 to our set. And we will move to the next element. 7 is not in the set, so we are adding 7 to our set. 1 is also not in the set, so we will add 1 to the set. We will move to the next element, which is 9. 9 is not in the set. We are going to add 9 to our set. And finally, we will reach the last element. We will check, is this element in the set? Yes, it is, because we already added 7. In this case, we would return true because we found a duplicate. If we were able to reach the end of the array and check all elements against the set, and we were not able to find any element that is already in the set, in this case, we would return false because that means we have no duplicates. And the time complexity for this solution is O of n. And space complexity is also O of n because we are using memory in our set to store the elements. And if the array has no duplicates, we would have to store all of them in our set. And that's the idea behind writing a linear solution for this problem. Let's write the code for our solutions starting from the brute force. So let's first store the size of the array in the constant. Now we will need to write 2 for loops. The outer for loop will be scanning through the entire array. And for our inner for loop, we will start from the next element after I, and we will try to find a duplicate. So to find a duplicate, we have to compare the nums of I and nums of j, and if they are equal, that means we found a duplicate and we can return true. And these 2 for loops will scan through the entire array. The outer for loop will go from element 0 to the last element, and the inner for loop will be searching for the duplicates. If we find a duplicate, we will return from the line 13. And if there are no duplicates, we will exit the for loops and we can just return false, which means the duplicates are not in the array. And that's the code for the brute force solution. Let's try to build it and run tests. So the build succeeded. Let's try to run tests, and the tests have passed. And that's our brute force solution written in C++. Let's write a solution that uses sort. So we need to include algorithm. and we start from sorting the array. So we sorted the array. Now we need to go through the entire array, starting from the second element, and compare the current element with the previous one. And if they are equal, we will be returning true. So let's write this code. So we are going through entire array, starting from the second element, so index 1. And inside we are comparing the current element, nums of I, with the nums of I minus 1. If they are equal, that means we found a duplicate, so we can just return true. If we exit the loop without finding a duplicate, we just return false, which means that there are no duplicates in the array. And that's the entire solution that uses sort. Let's try to build it. It builds okay, and let's try to run tests. And all tests have passed. We successfully coded the solution with the sort algorithm. Let's write a code for the solution that uses set. We will use unordered set in C++. So let's first define the set. Our set is a set of ints. Let's call it sin. And now we have to write a loop and process all elements in our array and check if they are in the set. If they are not, then we will add them to the set. Otherwise, if we find the element in the set, that means we found a duplicate. Let's write this code. So we wrote a for range loop, which goes through all elements in the nums array. And for each element, we check if our set contains a number. And if the number is there, then we return true. Otherwise, we have to insert that number into the set. And that's the entire gist of this algorithm. If we exit the loop, that means that we didn't find any duplicates, so we just return false. And let's try to build this. The build succeeded, so let's now try to see if the tests are passing. All the tests are passing, so we successfully coded a C++ solution using unordered set. Let's now make sure that our code passes all LeetCode tests. Let's start from the brute force solution. I'm going to copy the brute force solution. And let's see if that solution works. It works. Let's try to submit the solution. And we got time limit exceeded. So for the large data, our solution is too slow. So let's see if the other solutions do better. So now let's try the sort-based solution. Let's see if it works. It works. Let's now see if it's able to pass all the tests with the big data. And yes, this solution worked and we got quite a good performance. So now let's try our set-based solution. Let's see if it works. It works. Let's try to submit this one. And it works. For the test data in LeetCode, amazingly, the performance is worse than the sort. O notation is the worst case for really large data. It may not be working as you expect in real life. And that's the end of our verification of our solutions in the LeetCode. That's the end of this solution. The source code is available in the GitHub repo shown on the screen.